Hello viewers, you're welcome to Sales Arena Academy. In today's class, we'll be looking at waves and types of waves. If you are new to my channel, please click on the subscribe button to subscribe, and also click on the like button to like my video and share with your friend. Don't forget to put on the notification to receive any new notification whenever I release a video. Today, we'll be looking at waves. The first thing I'm going to be asking as a question is, what do we understand by wave? We believe that there are different forms of energy. As you have to know that each energy is a single form of energy: light energy, electrical energy, mechanical energy, sound energy. Now, wave is also a form of energy that is transmitted from one point to another in a medium. Now, what is the real definition of wave? A wave is a disturbance which travels through a medium, transferring energy from one point to another in that medium. Now, I made mention of a medium. Why are we using medium? In physics, medium can be classified into three, or let's say into four. We can have what we said, the liquid medium is an example of medium. We have a solid medium. We have a gaseous medium. And the last but not the least is a vacuum, a free space medium. Free space medium. Now, these are types of medium that can be used to propagate wave. Altogether, based on this medium, we are meant to understand that waves are classified into two types based on the medium that can be used to propagate them. Are we following with this? Now, among the types of wave that we have, we believe that one of the examples of this type of wave is sound wave, light wave, wave on a string, and the likes. But in how many types of wave, in how many types is wave classified into? Wave are classified into two types. The first type, we have what we call the mechanical wave. And the second type, we have what we call the electromagnetic wave. Now, I'm going to be taking you through each of these waves one after the other without wasting much of your time. But before I move on to this wave with their examples, let me try to explain something about medium. You see, a medium that can be used to transmit wave or to propagate wave must have this characteristic. Number one, it must be elastic in nature. What do you mean by elasticity? As you have to know that in physics, elasticity simply means the ability of a substance to change its shape and size and to return back to its initial shape and size after the effect of force or other material has been removed from it. Now, you see, in wave, we said wave transmits energy. What kind of energy is being transmitted by the wave? A wave is going to transmit what we know as kinetic energy. But the kinetic energy is being transmitted through the particles of the medium in which the wave is traveling. Now, we know that all matter must surely have particles that make up the matter altogether. Now, if a wave is to travel, according to his definition, he said it's a disturbance. It tends to disturb one or more of the particle by giving energy to the static particle. Actually, we believe that in a solid, the particles of solid are vibrating in their main position, performing vibrational motion altogether, while the particles of liquid are kind of sliding relative to each other. They are performing sliding motion But if energy is given to each of these particles, it increases their kinetic energy. Now, when the kinetic energy of each of these particles is being increased, the particle tends to start moving from one point to another. Are we getting what I'm doing? Now, when these particles are now moving from one point to another, let's say I have this, they tend to possess some forms of motion. They collide with each other. The collision of one particle to another particle makes this one also to collide with another particle. Now, this collision is done due to what? The energy that is being given to the particle. All together. So, the energy given to the particle in this case is in form of a disturbance. That is what we mean by this. Now, you see, all these particles, when they are given energy, they tend to return back to their initial position after they have been displaced. Now, when the sun displaced away from its initial position, it tends to hit particle that is nearest to it. All together. Then after hitting the particle, it returns back to its position. This also hits the next particle. It returns back until there will be transmission of energy from the beginning of the medium to the end of the medium. All together. That's obviously one of the properties of a medium is that a medium must be elastic in nature. It must be able to transmit and return back to its initial position. All together. Now, you now see all these three, solid, liquid, and gas, they are all called particle mediums. Altogether, each of these things contain particles. While this free space is known as a vacuum medium. A vacuum does not contain any particle, but a vacuum can serve as a medium for transmission of wave energy. Are we together? Now, let's take a look at the types of wave that we have. I said we have what we call the mechanical wave and the electromagnetic wave. What do we mean by mechanical wave? A mechanical wave is a type of wave that requires a material medium. Please, when I'm trying to classify, we classify based on maybe the medium is having material in it or it does not contain any material. You see these three mediums, solid, liquid, and gas. We call them material medium. Material medium. While this free space is a non-material medium because it does not contain any single material in it. Altogether, so according to the definition of mechanical wave are wave that requires a material medium for its propagation. Altogether, they requires a medium that requires a material medium for its propagation. That is what we call mechanical wave. And the greatest examples of this mechanical wave, we have the sound wave. Sound wave will never travel when there is no material, such as liquid, solid, and gas. It will never travel. Altogether, now we have sound wave. We have sound wave. We have water wave. Water wave is also an example of what? Mechanical wave. We have wave on a string. Although wave on a string can produce sound wave altogether, or we can take it wave on string altogether. Now, these are what likely example of mechanical wave that we have. But one thing I want you to understand is that light wave can also serve as mechanical wave. And I'm going to explain the reason for that. Now, that is for mechanical wave. We now have what we call the electromagnetic wave. From its name, it simply means that they are waves that are generated from the oscillation of electric and magnetic field in space. Altogether, these waves are generated. These waves are just only 6 in number. Altogether, we have 6 examples of this wave. The first example of this wave, which I'm going to be giving to you here, we have the gamma ray. Gamma ray. Each of these waves, they are in form of radiation. They are in form of radiation. Altogether, that's what we call them what? Ray. Now, we have the gamma radiation, we have the X-ray, we have the S-ray, we have the ultraviolet ray, we have the light ray, we have the infrared ray. Now, light, infrared, and we have what we call the radio wave. Although there is one in between it, which is also generated from radio wave. We call it what? The microwave. It's part of radio wave. But a radio wave, microwave is a radio wave of high frequency but low wavelength. That is microwave. Are we together? Now, these are the major types of electromagnetic wave that we have. You see, one thing about this electromagnetic wave, they are waves that does not require a material medium for their propagation. It simply means this wave can travel through vacuum. And also, when there is a material medium, they tend to travel through the material medium. Let's say, for example, you see this gamma ray. Gamma ray will surely penetrate into the body of human being, and it is dangerous. And also, X-ray, they will also penetrate through the body of human being. That's why many of the major applications of X-ray, it is used in medicine. All together, their radiation. Now, ultraviolet ray tend to penetrate into our body. Light ray can enter into water. It can travel through air, and it can also travel through solid. This wave can travel even when there is a material medium. That's why, according to this place, in mechanical wave, we say mechanical wave requires a medium. Now, light, all these electromagnetic waves too, although they will travel when there is no medium, and when there is medium, they will also travel. Are we together? Now, one thing about this electromagnetic wave that I want you to understand is that electromagnetic wave, they tend to vary. They vary in their speed. I'm sorry, they have the same speed. I'm sorry. Electromagnetic wave, they have the same speed, but they tend to vary in their wavelengths, and their frequency. Their wavelengths and their frequency, they vary with wavelength and frequency. Are we together? Now, based on their wavelength and frequency, we can easily explain this. Take a look at this. Now, you see, gamma ray is an electromagnetic wave of high frequency and low wavelengths. High frequency and low wavelength. That is for gamma ray. Are we together? Low wavelength and high frequency. That is gamma ray. Now, based on this, their frequency and their wavelength, don't forget I said something. I said all these electromagnetic waves, they have the same speed when they are in vacuum. When they are traveling in vacuum, they have the same speed, and their speed is 3 times 10 raised to 8 meters per second when traveling in vacuum. Now, you see, based on their frequency and their wavelengths, electromagnetic, they have a decrease in frequency when I'm moving from gamma ray to radio wave in this order. That means gamma has the highest frequency, while radio wave have the lowest frequency. So there is a decrease in frequency downward. Their frequency tends to decrease in frequency. Now, based on this order, gamma, X-ray, ultraviolet ray, light ray, infrared, radio wave, there is a decrease in frequency in that manner. But if the frequency is decreasing, the wavelength tends to increase from gamma to radio wave. Why? Because a frequency of a wave is inversely proportional to the wavelength. That means to say, if there is an increase in frequency, that wave with an increase in frequency will have a decrease in wavelength. Thank you for watching this video. Please stay with us to the end of this video so that you can enjoy the series. Thank you. If you are new to my channel, don't forget to subscribe to this channel and also drop a comment for me in the comment box section below. Thank you.